Welcome to the world of magnetic levitation trains. Yes, these are also called maglev trains, magnetic levitation. What is the meaning of levitation? I think that is known to you. The process by which an object is held aloft without any mechanical supports is called levitation. Means levitation is a process by which an object is held aloft without any mechanical supports. So in case of a magnetic levitation trains, there is no contact between the track and the train. There is a gap between the train wheels and the track by about a few inches. A few inches gap is there. That gap can be maintained. When the train is in motion, in that case that gap exists. Okay, when the train is in motion. And in China, a top speed of almost 600 km per hour. Actually, it is the recorded highest speed is 603 km per hour. And currently, three countries are there who are leading the charge in advancing this technology. Those countries are China, Japan, and Germany. And very soon, China is going to launch their maglev trains which can move at a speed of 1000 km per hour. And this speed is comparable with the speed of airplanes. That thing is known to you because the airplanes move at a speed of almost 850 km per hour or above. That is the average speed of airplanes. So their trains, means I am talking about right now China. Very soon they are going to launch their maglev trains, though in that case they are going to use a different technology. Normally in case of maglev trains, magnets are used for the purpose of levitation and for the purpose of propulsion. Means both for levitation and propulsion, magnets are used. Magnets, either they attract or repel. Okay, either they attract or repel, that is known to you. That is the fact of magnets. So, using this technology, the maglev trains, means magnetic levitation trains are also called maglev trains. From magnetic, mag is taken, and from levitation, lev is taken. So, it becomes magnetic levitation becomes maglev. Okay. So here magnets, powerful magnets, highly powerful magnets are used for the purpose of levitation. Means magnets are used both in the train and in the track. Okay, so that way what happens, there is no friction between the track and the wheels of the train. So friction is minimized, and that way one thing is there is low emission, so that is good for our environment. Emission becomes lower that way, and friction is minimum since there is no mechanical contact between the wheels of the train and the track during its motion. So therefore friction is minimized and wear and tear also minimized. So that way maintenance cost is also minimized. Maintenance cost of the train. Though we know that in India this facility is not available. There is no magnetic levitation trains available in India because high infrastructure cost is involved here. Infrastructure cost is very high. Okay, for the track as well as for the train. Both are highly expensive. Tracks as well as the train. Both are highly expensive because tracks are not only the metallic rails. Okay, technologies are also used there. Powerful magnets are also used on the tracks. So anyway, for the purpose of levitation, magnets are used. That way, levitation works. And for the purpose of propulsion also, instead of using traditional engines, magnets are used. Actually, motors are used. Linear induction motors or synchronous motors are used for the purpose of levitation. And you know this that these motors run by the presence of magnetic fields of very high strength, because a very high weight is being transported with so much speed. And this speed, I have mentioned the speed to be highest speed already achieved. That is recorded value is 603 kilometer per hour. So approximately you can say that magnetic levitation trains move at a speed of 600 kilometer per hour. Okay, and that is almost twice the speed of traditional trains. Though in India, if I talk about India, then in that case, what is the result? 600 by 2, that is 300 kilometer per hour. But in India, there is no train which can move at a speed of 300 kilometer per hour. The top speed has been achieved during its trial. I am talking about the train Vande Bharat Express. Vande Bharat Express. Okay. And during its trial, the top speed which has been achieved was 180 km per hour. But normally during their commercial operations, they reach to a highest speed of 160 km per hour. 160 km per hour. And the train is Vande Bharat Express. Few routes are there where these trains are operational. Okay. And very soon China is going to launch their special kind of magnetic levitation trains. Actually, in that case, hyperloops are used. Okay. Vacuum tubes are used through which the train will pass. Vacuum tubes. So a concept of hyperloop is used in that case. Okay. So China is very soon going to launch their train. Magnetic levitation trains. Those are also magnetic levitation trains, but some extra technology are being used there. And those trains will be able to move at a speed of 1000 km per hour. And that speed is comparable with the speed of airplanes. Okay. So, this was all about today's topic, magnetic levitation trains. Okay. So, if I ask you, whether we are defying, means these trains are defying gravity or not. Actually, the trains are not defying gravity. Whenever you are holding an object in your hand, is it defying gravity? No. Against gravity, you have applied one more force by using your hand. That's why you are capable of holding that object in your hand. So you are challenging the gravity that way. And here in this case of magnetic levitation trains, magnets are challenging the gravity that way. Okay. Anyway, so this was all about today's topic, magnetic levitation trains. So this is the end of this video. Thank you. Thank you for watching this video.